This video is to explain head loss. Pipes have pressure losses known as head loss due to two main things: elevation changes and friction. The sum of these two losses is the total head loss in a pipe. Elevation changes affect the pressure in a pipe because of the vertical distribution of the fluid. Fluid at the lowest elevation is subject to local pressure as well as the pressure building upon that from higher elevation fluid in contact with it. Also, there are friction losses which result from several different things: the velocity of the fluid, the size or inside diameter of the pipe, the roughness of the pipe, and the pipe's length. As velocity increases in the fluid, so do the pressure losses. In terms of the kind of pipe, a smaller diameter pipe puts more fluid in contact with it, thereby increasing the friction, i.e. the pressure losses. A rough pipe also increases this friction, and a lengthy pipe has more surface area and therefore more opportunity for friction loss as well. Finally, valves, fittings, and other components often contribute to the head loss in a pipe, but none of these apply to this particular problem. I have two straws of different diameters, identical lengths, and similar roughness. They will both be held vertically and subjected to an interior fluid of the same velocity. The only significant difference between these two pipes should therefore be the interior diameters. Knowing this, one may speculate that the head loss in the smaller pipe will be greater than that of the larger pipe. In other words, the flow of the larger pipe should be less inhibited by friction and pressure loss than the smaller, and therefore the water should flow out of the pipe at a much closer rate to that which had entered the pipe. The water flow in the smaller pipe, due to the higher head loss, should be even slower than that of the larger pipe. To demonstrate, I have 100 milliliters of tap water per pipe. Using the same measuring cup, I very carefully pour the water into each pipe at the same consistent rate. During a test trial, I found that the large straw passed the water several seconds faster than the small straw. Although some discrepancies are likely to exist due to the unreliability of my skills to pour the water at a consistent velocity, the actual timing should not be considered the only focus of this experiment. While running my first test, I immediately realized how the smaller straw inhibits the flow of the water. Notice how the water spirals around the inside of the straw due to the smaller diameter at the same velocity as the water flowing relatively straight downward through the larger straw. That observation in itself and without a stopwatch demonstrates the effect of head loss.